So here is the pi model. Pi model is drawn like this, kind of a resistor. Here is the current source and earth. This resistor is called as the beta Re dash. Here the current flowing is called as the base current. Here the current is flowing IC, means collector current, and the terminal is called as the collector terminal and emitter terminal. So we are basically right now taking one amplifier circuit. So conversion, all of you can get the conversion techniques. How can we convert the DC equivalent to AC equivalent? So DC equivalent circuit, I am taking one circuit that is a fixed bias circuit. All of you know that what is a fixed bias circuit. Here is a fixed bias circuit. Here we call this base resistance, collector resistance, voltage supply VCC. So here we are giving the input supply V in and taking the output over here. But sometimes they will give you the circuit like this way also, that coupling capacitors will be there for the input supply, and here we call the C1, C2 in this circuit, RB resistance, RC resistance, VCC supply. So don't need to worry about this capacitors, as we know that we have some rules about the capacitors and how can we convert this DC equivalent to the AC equivalent from the first rule or second rule or third rule. These three rules are most important. That first rule is need to be supply, DC supply, which is need to be short circuited. Second is capacitors, whichever capacitors are there, coupling or bypass, need to be short circuited. And third, replace the model with T or pi, as we have discussed T model and pi model. So first thing we need to do this in this circuit is we need to take this base resistance, collector resistance for simplify the circuit. So for the simplification of this circuit, what we need to do is that first thing is that the base resistance will be like this with the supply, that this is our input supply V in. With this input supply, the base resistance will be in the parallel combination. After this parallel combination, we can denote this term as RB, right or wrong? No, this is wrong. We need to denote this circuit with small letters, as we have discussed in the previous video. So this is the base resistance, whichever placed over here. We have converted that resistance with the input supply in a parallel combination. After that, transistor part will be there, and here will be the RC resistance. Right now we are writing the RC like this, and the load resistance, if it will be there, then we can show it like this, that this is our load resistance. Now if they are requesting you that convert this DC equivalent to AC equivalent by using T model, then you need to use the T model, or else if they are suggesting that you need to convert this model into the AC equivalent by using the pi model, then you need to use the pi model. Right now I am using the pi model for the conversion. So you can clearly get the idea about the conversion techniques. This can be asked in your exam, and more frequently they will ask you for this answer for 3 or 4 marks. So you need to go through this all the stuffs, and like this kind of thing will be done for the CB also, CC also, and CE also. This for all these three amplifiers we can do it the DC equivalent to the AC equivalent conversion. So now onwards we are going to understand that after simplifying this circuit, what are the different parameters we need to find out, what are the different parameters which will affect the performance of the amplifier. So uh, after this we need to get some more parameters, as we have already discussed some parameters in the previous lectures, like that this is the particular first parameter is that impedance input as well as the output, voltage gain, third is current gain, fourth is power gain. See, this kind of all the parameters we need to find out. As we know that circuit is now in a more simpler way, then we can easily get these values, and these values can be found out by taking one more example on the particular circuit or T model or pi model. One more circuit I am taking here, that VDB circuit is there, and VDB can also be asked for the conversion. VDB circuit is more popular for the biasing, and all of you can must be able to draw the VDB circuits for the conversion techniques. Here is the collector resistance and emitter resistance supply. There will be some input capacitors. Here will be the input voltage C1, C2, and here will be the bypass capacitor. We call it as CE. C1 and C2 are the coupling capacitors, and CE is the bypass capacitors. So for this circuit we can draw like that: R1 parallel to RL. This will be our supply, V input, and R1 must be